All right, let's go over the chapter 2 test. So, to start with, I carefully, hopefully, typed the equation into my calculator. You could do it in Desmos. This is a little easier on Desmos for this, but I want to look at the graph. And from the graph, I want to read the zeros. Well, there's something there. I'm not sure what that one is, but there is one that looks like it's at -2. So that's a 0, -2. And the graph looks like it's going straight through at -2. So I'm going to call that multiplicity 1. It's a factor once. And that's because it went straight through the x-axis. I'll abbreviate those ST later. Okay. The next 0 looks like it's right about there, and that doesn't look like it's a nice number. But it does look like at 1, it bounces off of the x-axis. At 1, a bounce, as we talked about in the class, tells us it's a multiplicity 2 or 4 or 6, but there's not enough of them. So this is 1, 2, 3. This is degree 5, so there must be 2 more. And we do see those, so they're real. They're there and there. To find those exactly, like I was kind of hoping you would do for this, we're going to do some synthetic division. So we're going to write down the coefficients of this thing in order of power. So the degree is 5, and we have -2 of x to the fifths. And then I have to ask myself, each power down, are there any x to the fourths? Yes, -6. If there weren't any, I'd have to put it 0. X to the thirds, 4 of them. If there weren't any, I'd have to put 0. X to the second, 14. X to the first, -6. And constant, x to the 0, if you will, -4. And when you do synthetic division, you always use the 0, not the factor. Now, -2 goes in and 1 goes in. I think 1's a little easier to work with, so I'm going to use the 1, and I'm going to do it twice. So here's the first time through. Add down. -2 plus nothing is -2. Multiply by the 1. Add down. 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 Multiply by the 1. And if it doesn't come out to be 0, then either this was not a 0, or I forgot to put a 0 in for one of the powers that I didn't have, or I've done my arithmetic wrong, or I didn't use a 0. Something's got to be wrong if it didn't go in evenly, if it is a 0 on the graph. And it looks like 1 goes in again, because it was a bounce, a multiplicity of 2. So add down, multiply, add down, multiply, add down, multiply, add down, multiply, add down. And it went in twice, evenly. And now I'm going to do the -2. See, I started with degree 5, and this is degree 4, degree 3. If I can go one more, I'll have a quadratic that I can use the quadratic formula on. So I'm going to do the -2. And I'm going to go through again, add down, multiply, add down, multiply, add down, multiply, and it went in evenly. And I'm left with the quadratic, negative 2x squared minus 6x minus 2. Was from x to the 5th to x to the 4th to x to the 3rd to x to the 2nd. And this was 4, 3, 2, x to the 1, x to the 3rd, x to the 2nd, x to the 1st, constant. So there's the quadratic, trying to find out what makes that 0. So I'm going to do the opposite of b, plus or minus the square root of b squared. Then I've got to take a minus 4 times a times c, so I got a minus times a minus times a minus, which is negative. 3 negatives multiplied is negative. 4 times 2 is 8 times 2 is 16, all over 2 times a, so that's negative 4. So I have 6 plus or minus the square root of 20 over negative 4. So my other two zeros are 6 plus the square root of 20 over negative 4 and 6 minus the square root of 20 over negative 4, and they both have multiplicity of 1, and on the graph they go straight through. And if I were to work out those values, see, this one looks like it's about negative 2 point something. I'm going to just figure out my first one here, see what it is in decimal. So I'm going to do, well, actually I could do it on quadratic formula, but I'll just do it here. 6 plus the square root of 20, and that divided by negative 4, and I get negative 2.618. Negative 2.618. That's that answer. And there's one right there. It's about negative 0.2 or 3. And that should be this other one. So I got to do 6 minus the square root of 20. And if I can't do the divide by unless I put parentheses around it, so it's easier just to go and divided by negative 4, and I get that negative 3.382. Now, completely factored. When I want to factor it, I like to first, let's take a look at that leading coefficient. If I write these factors, x minus a minus 2 and x minus 1 and x minus this and x minus that, I'll only get x to the 5th. I won't get a minus 2. So I'm going to say the factored form, I'm going to write it here, for f of x, it's going to have a minus 2, and it's going to have x plus 2, because it's always x minus the 0. So x minus minus 2 is x plus 2. That's going to be to the 1 power because it went straight through. It's going to be x minus 1, and that's going to be squared because it bounced. And then it's going to be x minus this. So it's always x minus. And so it's 6 plus the square root of 20 over negative 4. Now I could change the sign. This negative 4 could come out and change that to a plus. But I'm going to leave it like that just so it's clear what I'm doing. It's x minus this one, which is 6 minus the square root of 20 over negative 4. And there's it factored completely and exactly. Now I allowed on the test to have this number in here and this number in there. Okay. Y-intercept. Well, I could look at the graph, but that's pretty easy here. The y-intercept has x equals 0. If I put 0 in there, the only thing I get left is a -4. And the x-intercepts are -2, 0, 1, 0. It's a double 0, but that's still only one intercept. And then this, I allowed either version for the exact value would be 6 plus the square root of 20 over -4, and that is reducible, but not requiring the reduction, and 6 minus the square root of 20 over -4, 0. The in behavior, this is degree 5 and it's negative. Odds, they go either, if it's a positive coefficient, it goes this way, but since this is a negative leading a coefficient, the left end goes up, the right end goes down. And it does stuff in between, but in behavior is just what happens when you go far this way or far this way. This end's going up and this end's going down. Local maximums. All right, now we're going to bring the calculator back. Desmos, this is a little easier, but we'll do it on the calculator. Local maximum. This graph is coming down, and that's a minimum. Then it goes up here someplace to a local maximum. On Desmos, you can just tap it. On the calculator, we want to say it's a 0, somewhere between -2 and 0, a maximum. So you do that by doing second, calculate a maximum that's somewhere between -2 and 0, and it's about -1. And it says no, it happens at -1.244, but the maximum is 9.018. So the maximum is 9.018. Now for future reference, I'm going to write down that happens when x is equal to -1.244. You'll see why that's important in case you don't know why now. That was a maximum, but then it went down to a local minimum. Then it came back up, and that point is 1, 0. So there's another maximum of 0. That gets up to a height of 0 there. And it happens at x equal 1. So that might be helpful for some of these other parts coming up. Local minimums. Well, there's one right there. That's somewhere between -3 and -2. So I'm going to go second, calculate the local minimum between -3, enter, and -2. And I'm going to go -2.5 as a guess, and it says -2.36 is where it's at. Its value is -4.149. -4.149. And just for my information, I'm writing down where it's at. It was at -2.36. And there's another local minimum down here. That's somewhere between 0 and 1. So I'm going to go second, calculate the minimum between 0 and 1, and I'm going to guess it's about 0.5. And it says, no, 0.204 is where it's at. 0.204 is where it's at. But the value is -4.619. Okay, So we got 2 local mins, and we got 2 local maxes. Where is this positive? Well, this when we talking like that, when we're saying when f of x, the y values, the y coordinates for what x's is the y positive. For all these x's, the y values are way up here. And then they go to negative. They're all down below the x-axis. And then they go positive for these x's. Then it goes negative for these x's. And then it's negative for these. And it's 0 at those 3 places. Now, on this, I asked for positive. That means not 0. So it's above the x-axis for the x's from negative infinity up to that x-intercept, which was this one here. Now you can write it with the decimal. The exact would be this. So it's positive from negative infinity up to 6 plus the square root of 20 over negative 4, or that negative 0.268. And then it goes negative, and then it's positive starting at negative 2 and ending at that other irrational 0, from negative 2 to 6 plus the square root of 20 over negative 4, or you could have used the negative 0.382. So it was positive for all these x's, negative for those x's, then it's positive for these x's, then it's negative, 0, and negative, and so we only wanted positive, so we're done. And now when is it decreasing? This is when these are going to be important. It starts off infinitely high, and it's coming down all the way to that minimum. So it's decreasing from negative infinity up to the first minimum, which happened at x value of negative 2.36. For the x's, this is always in term. We're finding the x's where the y value is decreasing as x moves across. So it's decreasing all the way to this minimum. Then it increases to that maximum. So now we need to know the x value of the maximum because it decreases from there to that minimum. From this maximum to this minimum, it decreases. So we have from negative 1.244 up to the minimum. That's 0.204. It decreased from this max to this min, and then it went up, increased to there, and then from 1 on, the function is decreasing. So union from 1 to infinity, it continues to decrease. Okay, that's number 1. Let's do number 2. Number 2, if we're going to punt the football and it's in feet, the height as a function of time, or you can use x if you want. If you're doing height in feet, it's negative 16. And if we want it to be 0 when he kicks it, we're going to have to put in t. And when it lands at 5.2, we're going to have to put in t minus 5.2. So this will be at ground level at time 0 and at 5.2 seconds. If I want to know the maximum height that it reached, I would put the time right in the middle, which is 2.6, into this equation. Or I could graph it. and tap on the maximum. I'm going to type in the equation using x's, of course, negative 16x parentheses x minus 5.2, and turn this one off, and I've got my table set on ask for the independent variable. And when I have that, I can go to table, and then I can get rid of these and put in what I want to know. I want to know at 2.6, and it's at 108.16 feet high. And then I need to know at 2 seconds and 3 seconds. So I'm going to put in 2. So at 2 seconds, it's at 102.4 feet high. And at 3 seconds, it's at 105.6. So it's going up. So 105.6 minus 102.4 is 3.2 feet. It went up in 2 to 3 is 1 second. So it's going at 3.2 feet per second on average in that change of time from the second to the third second. And if I want to know just before it reaches the ground, I'm going to do basically the average velocity, but really close to when it hits the ground. Now it hits the ground at 5.2, so I know that if I put in 5.2, I'm going to get 0. I'm going to just check that. And let's do just before it hits the ground, like 5.1 seconds. And it's at 5.1 seconds, it was at 8.16 feet. So the change in height, it went from 8.16 to 0, so it went down 8.16 in this last 1/10 of a second. This minus this is 0.1, which turns out to be negative 81.6. And the numerator was the change in the height, feet, and the denominator was in seconds. All right, shifting gears completely, complete the square. Now, when we complete the square, we pull the leading coefficient, we factor it out of all the terms with the variable. So we're going to write f of x is going to be 2 parentheses, and it's going to be x squared because 2 times x squared makes 2x squared, and it's going to be 2 times negative 6x, because I'm dividing out the 2 there, which makes that a 1, and dividing a 2 out of there, make it negative 6. And then we always have plus something minus something when we complete the square, and we leave the 3 dangling at the end. We then say, I want to make a perfect square, complete the square. What x plus or minus what will start looking like this if I multiplied it out? Well, it's always half of this number, so that's minus 3. And if I multiply out x minus 3 times x minus 3, I get x squared. I get minus 3x and minus 3x. That's the minus 6x. But there's a plus 9, this negative 3 squared. So I can't change this problem by adding 9, so I got to subtract the 9. These 3 terms are what this perfect square is. This multiplied out is that. So this is in here, and I still have this minus 9 that's inside this 2. So now I need to distribute the 2. So I have 2 times the x minus 3 squared, 2 times the negative 9, and then the 3 hanging out on the end. So I have 2x minus 3 squared minus 15, which says this is a parabola that's moved 2 to the right, so the vertex, which you could have gotten by just clicking on it or going minus b over 2a. It happens at 3, and it's moved down 15. So you could just graph this on Desmos and get that, and the center line, of course, then, or axis of symmetry that I asked for, is at x equal 3. It's an equation. It has to have a variable in it. It's straight up and down, vertical line, so it's x equal 3. So you could have gotten these two just from graphing it. But I only gave 1 point because I wanted you to show me that you know how to complete the square to get them. So I'm looking for the completing the square. That's the important part of this. Do you know how to complete the square? Number 4, the parent function here is a parabola, y equals x squared. And so the parabola, you should know, 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4. I'm looking for those 5 points on the parent function. I want to see them on the graph. And I want to see that whether you're calling each square 1 unit or 2 units or whatever. So it's 1, 2. So every unit squares 1 unit. Now you can choose to do the inside stuff first, the horizontal transformations, or the vertical transformations first. In class when I went over it, I did the horizontal ones first. I'm going to do the vertical one first on this. So we got to move this graph up 1. There's only one thing on the outside, so I can just go ahead and do it. So I got to move my parabola up 1 unit. And if I go over 1, it's up 1. Over 2, it's up 4. Or this point moved up 1 is at 1, 2. And this point at 2, 4 is now at 2, 5. Each of these 5 points got moved up 1. So I need to know that I'm still using a scale. Every square is a single unit. So that's vertical. Up is in the vertical direction, so I know that. So now I got to work on the inside, and there are 2 of them. Multiplication becomes before addition according to the order of operations. So when we're doing transformations on the inside, we do them backwards. Everything's opposite. So instead of multiplying, we're going to take care of the 3 first. It's add 3, so you would think it would go right, so it goes left because everything's opposite. So I got to go right, a left 3, so I'm going to move my y-axis way over at the edge. And I got to take this point 3 over. 1, 2, 3. This point 3 over. It's 1 to the right, so now it's 2 to the left. And this one is going to be here, here, and there. And my scale is 2, and this is a negative 2 if every square is 1. So I went left 3, or horizontally 3 to the negative 3 units, okay? And then finally, I got the 0.5. And it's inside, so you would think 0.5, half, would make it half as wide or half as far from the y-axis, but it does the opposite, so it makes it twice as far from the y-axis. So if I continue to use the same units, where this is -2 and this is +2, I look at how far this point is from the y-axis, 1, 2, 3, and I move it twice as far. 1, 2, 3, 4, 5, 6. This point goes to there. This point is 2 over, so it goes 1, 2, 3, 4 over. This point is 1, 2, 3, 4, so it goes to 8. 4, 5, 6, 7, 8. This one's 1 over, so it goes to 2. This one's 5 over, so it goes to 10. 8, 9, 10. Woo. So it's going like this. So that's a horizontal stretch by 2. So where did -1, 1 end up? Well, it got moved up 1 by the +1. Then it got moved left 3. And then it got moved over twice as far from the y-axis from this one. So it ended up here at -8, 2. So where did that end up at? Okay. Page 3, problem number 5. Divide. So we just got to do the division. Nothing fancy about it, just do it. 4x to the 5th minus 2x to the 3rd plus 3x plus 6. I have to ask myself, what do I multiply this by to get that? I have to multiply by a 2 and x to the 3rd to make x to the 5th. So 2x to the 3rd. Oops, sorry, bumped that. Hold still here, camera. There we go. Then I got to take this times both of these. So I take 2x to the 3rd times 2x to the 2nd makes 4x to the 5th. 2x to the 3rd times 1 is plus 2x to the 3rd. Now I'm supposed to subtract in normal division, so it gets confusing, so I draw the line, change the signs, and now combine like terms. 4 of these minus 4 of these, gone. These are x to the 3rds, minus 2, and minus 2 more is minus 4x to the 3rds. There's only, and then there's a 3x out here, and a 6. So I say to myself, what do I multiply this by to get that? Well, 2 times -2 would make -4. And x squared times x would make x to the 3rd. So I got to take a -2x times this. -2x times 1. And now to avoid subtraction, I'm going to draw the line and change the sign. So now I can add. These add up to be 0. These add up to be 5x plus 6. Can't multiply x squared by something to get x. Not any, at least not something that doesn't have an x in the denominator. So this is my remainder, and the remainder is added to what I was my quotient was, but divided by what I was dividing by. I still need to divide this remainder by 2x squared plus 1. So there's the answer. Now, synthetic division's a bit easier. I got x to the 4. That's my leading coefficient is 3, so I'm going to put it first. That's 4, so I have to ask myself, are there any x to the thirds? And I don't see any, so I have to put in a 0. Then I say, are there any x to the seconds? And there's minus 2. X to the first, they're 5. And constant. And I use what makes it be 0. So if I'm dividing by x minus 3, 3 minus 3. So I use 3. Add, multiply, add, multiply, add, multiply, add, multiply, add. This was x to the 4th, so my answer when I'm dividing by x minus 3 is 3x to the 3rd, goes down by 1, plus 9x squared plus 25x plus 80 plus my remainder over what I was dividing by. All right, to the last page. Degree 4, and it has these zeros. 3 with a multiplicity 2. Well, if 3 is a 0, then x minus 3 is a factor, and if it's got multiplicity 2, it's squared. And if I have negative 5i as a 0, the I comes from doing a square root in the quadratic formula, so if I have real coefficients, then the other one has to be, it's plus or minus the square root part, so it must be plus 5i. So if I write the factor with that in it, it's going to be x minus a minus 5i, which is plus 5i, and x minus a 5i. And there could be any number in front of this. I'm just going to leave it 1, but it could be a 2 or 5 or negative 3, but this is a polynomial that has 3 as a double 0 and negative 5i and plus 5i as zeros. And you can multiply it together if you want, but it's not necessary. Now, the book does these a little differently than I do. I like to just say, what do we know about this? If this was f of x equal this, ignore this for a sec. It has a 0 at positive 4. 1, 2, 3, 4. It has a 0 there. In fact, it's a double 0. It bounces there, so I'm going to write a little b above it to remind myself it's a bounce. It has a 0 at 2. And it happens only once, so it must go straight through there. And it has a 0 at negative 1, and it's squared, so it's got a bounce there. And if I looked at this, I got x times x times x times x times x. It's going to be 1x to the 5th for my leading term. It's positive 1. And a 5th degree would start on the negative side, come up, come down, come out. Anyway, so it's got to come up, and it bounces here, so it must just come up and bounce. Then it went straight through here, and then it came down, and it bounced there. Now, I could just type that into my calculator and see that too. But I'm looking for when y is less than 0. For what x is on here is the y-coordinates less than 0. The y-coordinates are less than 0 here, here, equal to 0 there, equal to 0 there, and equal to 0 there, greater than 0 here, and greater than 0 there. So for these x's up to -1, the y-coordinates are less than 0, equal to 0 there, and I didn't want equal, didn't say less than or equal to 0. Union from -1, it's equal to 0, but from after that all the way to 2, their y-coordinates are less than 0. So from -1 to 2. After that, the curve is always positive or 0, so there's no more places where it's negative, less than 0. And now the final problem. Polynomial. Well, just looking at the graph, it's bouncing at -2. That means x plus 2 must be a factor twice. And it goes straight through at +2, so that means x minus 2 must be a factor once. And it goes straight through at 3, so x minus 3 must be a factor once. And there could be some number that's times it, and that would be my function, or y. And they say if I put 0 in for the x's, I'm supposed to get -2. So I'm supposed to get -2 if I put 0 in for the x's. So 0 plus 2 is 2 squared is 4. 0 minus 2 is -2, and 0 minus 3 is -3. And these multiply to be -2. See, that's -8 plus 24. So I'd have to divide by 24, which reduces to -1/12, and that's what A would have to be, or -2/24, either way. And so there's what the function is.